Is it good morning? Yeah, good morning. I'm going. Yeah, so I'm going to be revising some grade 8 term 1 stuff. Why? Because obviously we are going to be going into term 2 work, but it would be nice to just do some quick fire recap of the content that grade 8s have done in term 1 so far, so that we can clarify any sort of like concepts done and also close any gaps that the grade 8s may have. So let's start right here. Use the distributive property of natural numbers to complete the following. So guys, this law or this property called the distributive property of natural numbers to complete the following. So what we have here is 5 times, and then in brackets we have 2 plus 6, close the bracket, and they are asking us to use the distributive property. Okay, a property that we use to distribute, okay, natural numbers to complete the following. So we have a 5. 5 is a natural number. We have multiplication. We have a bracket. We have 2 and we have plus 6. Okay, so they are saying let's complete this mathematical sentence. So this will be using the distributive law. This will be 5 times 2, because the 5 gets multiplied to the 2, then there's a plus sign in between, then we say 5 times 6. Okay, so what's happened right now is that we took the 5, we multiplied it with 2, because brackets in maths mean multiply. 5 times 2, the plus sign, 5 times 6. And that's the using the distributive property of natural numbers. We've completed this mathematical sentence. Let's continue. Use the commutative property of natural numbers to complete the following. So we have what we call the commutative property. The commutative property speaks to the fact that it doesn't matter the order in which you place numbers in multiplication and addition, because you get the same answer. So for instance, if we're going to use the commutative property of natural numbers to complete the following, then we say 5 times 2 is equal to 2 times 5. Alright, simple, straightforward, just like that. Let's go on. Does the commutative property also apply to the following operations? Does the commutative property also apply to the following operations? Does commutative property, guys, apply to addition? Does it matter the order in which we place numbers when we are adding, and do we still get the same answer? That's the question. So for instance, for addition, if I take 1 plus 2, and I take that 1 plus 2, I change it up and I say 2 plus 1. The question is, do I get the same answer? Yes, I do, because 1 plus 2 is the same thing as 2 plus 1. So for addition, does the commutative property apply to addition? The answer is yes, it does. Does the commutative property apply to subtraction? That is the question. Does the commutative property apply to subtraction? So in other words, if I have 2 minus 1, is 2 minus 1 the same thing as 1 minus 2? Because commutative property has to do with changing the order of these particular numerical numbers whilst maintaining the sign in between. So 2 minus 1, is it the same thing as 1 minus 2? Well, 2 minus 1 is 1, whereas 1 minus 2 is negative 1. So does the commutative property work in subtraction? Does the commutative property also apply to subtraction? The answer is no. Lastly, does the commutative property apply to division? So, in other words, is 18 divided by 3 going to give us the same thing as 3 divided by 18? That is the question. So 18 divided by 3 is obviously giving us 6. But if we change the order, 3 divided by 18 is 1 over 6. So we can see that our answers are different when we change the order for numbers that are divided. So does the commutative property also apply to division? The answer is no. So when we talk about commutative property only applies to addition. And if they had asked us, does it apply for multiplication? What would have been our response? Does the commutative property apply to multiplication? And to make a quick example, is 3 times 2 going to give us the same thing as 2 times 3? That is the question. Does the order matter in multiplication? Well, we can clearly see that for multiplication, the order in which we place our numbers does not matter. So the commutative property for multiplication, does the commutative property apply to multiplication? The answer is yes, it does. So we can see, guys, that for multiplication and addition, commutative property does apply. But for subtraction and division, the commutative property does not apply. The word commutative has to do with how we place numbers and in what order. So if we change up the order in division and subtraction, the answer does not stay the same. But if we change the order in addition and multiplication, the answer stays the same. So the commutative property applies to addition and it applies to multiplication. Let's move on. Are the following statements true or false? Are the following statements true or false? 2 times brackets 3 times 4 close the bracket is equal to 2 times 3 brackets times 4. True or false? Is this mathematical statement correct? True or false? Okay. 2 times brackets 3 times 4 is equal to 2 times 3 in brackets times 4. If you can see here, the bracket is around the last 2 numbers that are multiplied, but the same numbers are multiplied in both the left and the right. But here we put the bracket, the last numbers. Here we put the bracket, the first 2 numbers. The question is this equal to that? Is this true? True. Yes, it is true, because we are dealing here with what we call the associative property of multiplication. What do we call it? The associative. So in the midst of your multiplication of these 3 numbers, we associate or group 3 and 4 in brackets with the same order of numbers. We associating 2 and 3. So therefore we say that this is truly equal to that. It's true, not false. the property that we are using is the associative property. Let's come here. Is this following statement true? We have 2 times 3 plus 4, and we have 2 times 3, and then with the plus 4 on its own. Is this statement really true? So let's look at it carefully. According to BODMAS, we always start with what is in the brackets. 3 plus 4 here is 7. And then we take the 7 and we do multiplication. 7 times 2 is 14. So we get 14 from the answer that we get here on this side. Let's come here. BODMAS says we start with brackets. So 2 times 3 here is 6. 6 plus 4 is 10. So in other words, we are getting 14 on the left whilst we are getting 10 on the right. Is this statement true? The answer is the statement is false, right? And of course, this is not applying the associative property. The only reason here we said that it is true and we are applying the associative property is because there is one single operation that is evident on the left hand side here. It's multiplication. So 3 times 4, for instance, in brackets will give us 12, whilst 12 times 2 is 24. So we easily get a 24 here. And this side, 2 times 3 is 6. 6 times 4 is 24. We also get a 24 here. That's why we said this statement is true. But here, this statement, when we apply BODMAS, is incorrect and it is false. So that is why we say the statement is false. Let's move right along. 0 divided by 5 is equal to 0. Is this true? Is this a true or is it a false statement? 0 divided by 5 is equal to 0. Guys, is this true? Can someone vouch? True or false? It would be nice for us to use the comment section. 0 divided by 5 is equal to 0. Is this true? Okay, it seems like my comment section is very quiet. Okay, 0 divided by 5, guys. Is it equal to 0? Yes, it is. 0 divided by 5 is equal to 0. So we say this statement is true. 5 divided by 0, is it equal to 0? Is this statement true or is it false? 5 divided by 0, is it 0, guys? Is it 0? Is 5 divided by 0 actually equal to 0? Okay, rele in the comment section, or is it rele or rele? I don't know which correct way I'm pronouncing. Is it correct? Okay, so 5 divided by 0, guys, is not equal to 0. Rather, 5 divided by 0 is undefined. So 5 divided by 0 equal to 0, we know that that is false. A number divided by 0 rather is undefined. Okay, undefined. Okay, let's move right along. 10 plus 12 divided by 2, is that equal to 5 plus 12? So let's come here and check what's 10 plus 12. It is 22. What is 22 divided by 2? Because we are applying BODMAS as we work here. We deal with what is in the numerator. 10 plus 12, which is 22. 22 divided by 2 is 11. So we have an answer of 11 on the right. Sorry, not here. 11 here. 5 plus 12 is 17. Now 11 is not equal to 17. So that means this statement is definitely going to be what? False, not true. Let's come down here. The square root of 9 plus 16. Is this equal to the square root of 9 plus the square root of 16? True or false? Square root of 9 plus 16, is it equal to the square root of 9 plus the square root of 16. True or false? What is it, guys? Is this a true statement? That the square root of 9 plus 16 inside the square root is the same thing as the square root of 9 plus the square root of 16. True or false? Are the following statements true or false? Square root of 9 plus 16 inside the square root, is it equal? Is it the same thing as the square root of 9 plus the square root of 16? I'm waiting very patiently, guys. Let me know in the comment section if the square root of 9 plus 16 underneath the square root is the same thing as the square root of 9 plus the square root of 16. Is it? Rele is saying it's true. You'd be very surprised, Rele. Let's check it out, Rele. Inside the root, we have 9 and we have 16, and they can be added together. Okay, 9 plus 16 is 25. If we apply the square root to 25, we get an answer of 5. So we can confidently say that on the left hand side, our answer is 5, because 9 plus 16 can be added together, it's 25, and the square root of 25 is then 5. If we go to the right side, the square root of 9 is 3. We add the square root of 16 is 4. What is 3 plus 4, guys? It is 7. The answer you got on the right is 7. The answer you got on the left is 5. Is 5 equal to 7? I'm sure you can see very well that 5 is not equal to 7. But what is the mistake learners are making when it comes to the square root of 9 plus 16? Learners think that the square root of 9 plus 16, you can split the square root when you are adding. And guys, the truth is we cannot split the square root when adding. We can't split the square root when adding. We can't split the square root when subtracting. The only time we can split the square root is when we are multiplying and when we are dividing. So that is why, for instance, this is not the same as that. I hope you've heard me well. We can't split the square root when adding and subtracting. We only split the square root, or any root in actual fact, when multiplying and dividing. So that is why, for instance, these answers are not the same. Let's move on to number 7. 3 plus 4, the whole thing squared. Is it the same thing as 3 squared plus 4 squared? True or false? So this one above was false. I'm asking now, true or false? 3 plus 4, the whole thing squared. Is it the same thing as 3 squared plus 4 squared? True or false? 3 plus 4, the whole thing squared. Is it the same thing as 3 squared plus 4 squared? Three plus 4, the whole thing squared. Is it equal to 3 squared plus 4 squared? Okay, very silent in the comment section. 3 plus 4 squared. Is it the same thing as 3 squared plus 4 squared? True or false? Rayleigh says false. Brown says false. Okay. Okay, you guys are saying false. Can I just ask, in the comment section, guys, can you tell me what is the outcome of 3 plus 4, the whole thing squared? What do we get? You guys are the ones saying false, so I want to check. What's 3 plus 4, the whole thing squared? What do you get for your answer on this side? Three plus 4, the whole thing squared. What do you get for your answer on the left? Okay, what about the Bodmer's rule? Bodmer's rule applied, yes, so I want the answer. Very good. I love that, Brown, that you're saying Bodmer's rule. So what then is the outcome? B, brackets. So inside the brackets, can we do anything with what is inside the brackets? Because B means brackets, O means order. Orders means exponents and roots. So we do have brackets and we have an exponent. So we deal with the bracket first. 3 plus 4 is 7. You apply the exponent 2 to 7. What is 7 squared? Okay. 7 squared is the same thing as 7 times 7, which is actually equal to 49. So you get 49 on the left. Agreed. Okay, very good, Rayleigh. Then on the right, what is 3 squared plus 4 squared? So once again, Bodmer says brackets, no brackets. Exponents, let's deal with the exponent of each number. 3 squared, what is it? 4 squared, what is it? And we can do addition and subtraction later on. BODMAS. What is 3 squared? And then what is 4 squared? You can add those two numbers together that you get. So 3 squared is 9. 4 squared is 16. What's 9 plus 16? 25. So you have a 49 on the left, you have a 25 on the right. Is 49 equal to 25? No. So you guys were 100% correct, Rayleigh and Brown, when you said it is false. Okay. The square root of 25 over 4, is it the same thing as the square root of 25 over the square root of 4? And so can you, just by looking at this, tell me true or false without necessarily having to calculate this? Because more than just calculate, there are rules when it comes to the square root. Okay. If you remember earlier on, we said the square root, if there's addition and subtraction under the square root, we can't split. So when there's addition and subtraction under the square root, splitting cannot happen. That's why this and that do not basically equate. They don't give you the same answers. But now we have 25 over 4, which means 25 divided by 4 inside the square root. And then here we have the square root of 25 over the square root of 24. Is this equal to that? Is this a true statement? Is this true or is this false? Is the square root of 25 over 4 equal to the square root of 25 individually over the square root of 4? True or false? That is what I'm asking. You need to give me a true or you need to give me a false. Given math says it's true. Okay, that's one person. Rayleigh says it's true. That's the second person. And Sims also says it's true. So hopefully, guys, we all can say confidently this is true. The reason we can say that is because splitting the root for division is true, whilst we know that splitting the root for addition or subtraction is not true. That is why this was not equal to that, because we can't split the root for addition and expect that the answer is going to be the same. But if we split the root for division and we can split the root for multiplication, we can definitely expect our answer to be the same. So this is true. Very good, guys. We get 5 over 2 from the left. We also get 5 over 2 on the right. Okay. So that's 100% correct. Let's move right along. Calculate the values of the following without using a calculator. So guys, all these 1 marks, I would get them most. I would be getting full marks here because I did everything 100% correct, applying the right methods. Brown is saying, if you were my teacher, would have went far. Oh dear, thank you so much for that compliment. It means the world. Guys, I appreciate any yeah. This is funny because now all of a sudden it's like me coming in and I being like, appreciate any gifts, guys, that you can send through. Yeah, just to support the live, it would be much appreciated. Thank you so much for the heart, me Brown. Brown, what are you doing, by the way, like with the live? I can see some nice rolls there on the hair with your profile picture. Are you perhaps in the hair business? Okay, so let's calculate the values of the following without using a calculator, guys. So the whole point here is to basically show the steps. There's 2 marks. We want to show the steps in our calculation. We don't necessarily want to just grab the calculator and punch in the values. Okay, we don't want the answer, because when they say calculate, the thing hidden here is that you must show steps. That is what warrants you getting marks, because if they say calculate, the implied instruction is that you must show your steps, and they don't want you to just simply go and write the answer. Because if you go simply and write the answer, it's like you have basically not shown the steps. So that is basically the implied instruction that is hidden in the word calculate. If they say calculate the values of the following without using a calculator, you must show your steps. So if we have the square root of 25 minus 9, thank you so much, Brown, for the Go Popular, really appreciate it. So the square root of 25 minus 9, first and foremost, BODMAS tells you guys that you start with brackets. Guys, the implied thing is that underneath the square root, you actually have, like I said, a numerical expression. And this numerical expression, okay, this numerical expression, 25 minus 9, this is 2 things underneath the square root, 25 minus 9, okay, yeah, 25 minus 9, okay, yeah, so the 25 minus 9 underneath the square root, you are just going to go ahead now and you are going to subtract what is inside the root, because BODMAS says brackets, so it's like these things are in brackets inside, and then you apply the root afterwards, because O in BODMAS means orders, and orders means exponents and roots. So after the subtraction, which is 25 minus 9 is 60, you then can apply the square root to 16. Does that make sense? So that is why step number 1, you get a mark for writing square root of 16. Step number 2, writing the answer. Square root of 16 is 4. you get your second mark. Are you with me, guys? Remember what we said earlier on. We said we cannot split the square root for subtraction and addition. All right, we can't say here the square root of 25 minus the square root of 9 to simplify and calculate the square root of 25 minus 9. Why? We do not split the root for addition and subtraction. We only split the root for multiplication and division. let me explain, or probably through another example, make this point very clear. Say they said calculate the values of the following without using a calculator. Do you see what you have here? Inside this root you have 25, but it is multiplied with 9. What do you notice underneath the root? You have multiplication of two numbers. So here you can go ahead and apply the law of splitting the square root, because the operation between 25 and 9 is multiplication. Then what is the square root of 25? It is 5. What is the square root of 9? It is 3. And then 5 times 3 is 15. So this is what I mean by we cannot split the root for addition and subtraction, but we can definitely split the root for multiplication and division. So step by step, this is how my calculation would unveil. All right, as I said, in the word calculate is the idea that you need to show your steps. So your mathematical conceptual understanding is then revealed and it's applied, because you know the rules attached to this. Okay, so I hope that makes sense, guys, and yeah, it's clear for you. Let's move on. Square root of 25 minus 9. Okay, so of course we have minus in between. The square root of 25 is separate from the square root of 9. So here we need to simplify without using the calculator, step by step. So what do we do here? Hi guys, 25 is under a root, 9 is under a root. 25 is a perfect square number, 9 is a perfect square number. We apply the square root to a perfect square number, we should get a natural number. So the square root of 25, hi, very straightforward, guys. Now some people would think that, my question is here, could you perhaps use the calculator? Yes, you could use the calculator. Would anyone know that you use the calculator? No one would know that you use the calculator. The only thing that you need to make sure that you do is show the steps. Maybe someone does not know what the square root of 25 is. They grab their calculator, they say square root of 25, then obviously, what is the square root of 25? Bam, it's 5. Okay, you place the minus sign. What is the square root of 9? Bam, the answer is 3. Okay, then here, very clear what we can do next. Do we get marks? Yes, indeed we do. We get the marks for ensuring that we get the square root of 25 and the square root of 9. And all we have to do now is just take care of the subtraction. 5 minus 3, as you guys will well know, is actually 2. BODMAS is being applied nicely here, because what does BODMAS say? BODMAS says brackets, which is for B. O means orders. Orders means exponents and roots. So we take care of the roots, because O means orders, which means exponents and roots. Square root of 25, 5. Square root of 9, 3. Then after that, D means division. M means multiplication. We don't have any of those. A means addition. We don't have. S means subtraction. We take care of subtraction. In that order, we get the answer. Then basically that's boom, second mark in the bag. Let's come here, guys. The cube root of 21 plus 3 times 2. The cube root of 21 plus 3 times 2. So once again, in our head, we are like, Mr. Podmas, brackets, no. Orders, of course, the root, but then the thing is, we are going to take a look at what is inside before we apply the root to what is inside. We take a look at what is inside. So we go back to what is inside and we re-look at it and apply BODMAS to what is inside. So what we have is 21 plus 3 times 2. We can't do addition. We must first take care of multiplication inside the root, because according to BODMAS, multiplication comes before addition. So if we were to say 21 plus 3, we are being completely wrong in the order in which we are doing the maths. We first have to take care of the multiplication. So for now, we keep the cube root and then we say 21. What's 3 times 2? That gives you 6. Okay, that's the first mark that we are getting for actually taking care of the multiplication. Then what is 21 plus 6 inside that cube root? That gives us 27. Then in your head, you are like, what is the cube root of 27? Guys, remember, 27 is a perfect cube. Why am I saying 27 is a perfect cube? If you take 3 and you multiply it by itself twice, you get 27. This 27 is what we call a perfect cube number. Anytime, guys, you take a natural number and you multiply it by itself twice, you get what we call a perfect cube number. A perfect cube number, applying the cube root to it, should give you an actual natural number. So we could grab our calculator at this stage and put the cube root of 27 and get the actual answer. The steps is what is beautifully shown. And therefore, when we conclude and we say the answer is 3, we say the answer is 3, at least having shown the steps according to BODMAS. You will understand that for inside this root, this was the multiplication that we applied. 21 plus 6 to get 27, we applied the addition. Then ultimately, after having sorted what is inside the cube root, then we can apply the order, meaning the root, the cube root to the 27. Okay? You want to see me calculate. What do you mean see me calculate? Because the calculating is me actually doing this step by step according to BODMAS. Or are you saying you want to see me using the calculator? Is that what you are saying? I don't understand. Are you saying you want to see me calculate? You want to see me using the calculator so you can see the emerging of 3 as the answer when I use the calculator? Or are you saying, I'm trying to understand what you mean. So please, can you clarify in the comment section, what do you mean? Calculate means I need to show the steps. And these are basically from here to get to this place. We applied the multiplication, which according to BODMAS, in the order, we need to first start with multiplication for what is inside the cube root. That's why 3 times 2 is 6. We keep 21, 3 times 2 is 6. All right? So 21 plus 6 is the initial step. Then, after multiplication, what follows is addition. So now 21 plus 6 is going to give us what? 27. That is the next step. Addition has been applied. Now we can apply the what? The cube root to the specific number inside the root. So what is the cube root of 27? The cube root of 27 is 3. Final answer. So I don't know if Brown, does that answer your question, or is there something that you are asking me to do specifically? by calculate, remember I said when we say calculate, we are not saying that we should simply punch this into the calculator and get the answer. No, no, no. By calculate, the implied instruction is that we need to show steps. And in order for that to happen successfully, we need to apply BODMAS at every turn, so that the person who's looking at the work and you were doing the work can see how the answer emerged from one step to the other. So I don't know, okay, if that answers your question or okay, all right. Okay, so we can go on then. Okay. Okay, then let's just see something here. I want to see something here. Boca, is it Boca 13? What's up? Hey guys, if you guess request and then you run, I don't know how do you intend for me to help you. Okay, now grade 8s. The other thing that grade 8s have been taught is how to find the lowest common multiple between two numbers. Okay, now to find the lowest common multiple between two numbers, remember the multiples of 12, okay, are numbers that you get. Remember multiples, if you say 12 times 1, 12 times 2, 12 times 3, the emerging numbers that you get are what we call multiples. So when you say 12, 24, 36, you counting in 12s is you actually writing down the multiples of 12. 18, you counting in 18s, right? 18 times 1, 18 times 2, 18 times 3, you counting in 18s is you basically telling me what the multiples of 18 are. Okay, so basically this is what we mean now. They want us to find the lowest common multiple of 12 and 18. So if you write down the multiples of 12, 24, 36, you write down the multiples of 18, 36. Okay, remember these multiples. How am I getting these multiples? If you multiply 12 by 1, you get 12. Multiply 12 by 2, you get 24. Multiply 12 by 3, you get 36. Multiply 12 by 4, 48, and so it goes. Take 18 as the number and find the multiples of 18. 18 times 1 is 18, 18 times 2 is 36, 18 times 3, and so it goes. So basically what I'm saying is, you count in 12s, the multiples of 12 come out. You count in 18s, the multiples of 18 come out. Now they are saying here, find the lowest common multiple. All right, so from grade primary school, like grade 7 and below, I believe that our learners are learning how to find the lowest common multiples by simply counting either in 12s or counting in 18s, because here they are saying find the lowest common multiple between 12 and 18. Okay, but then in grade 8 we expose the learners to a method of finding the lowest common multiple using the ladder method of finding the product of prime factors from 12 and 18 and then getting the lowest common multiple. So I just want to touch on the primary school method. The primary school method simply took two numbers or three numbers or however many numbers they want the lowest common multiple of. And the first thing that you do is you write down the multiples of the numbers that you are given. So for instance, the multiples of 12 are 12, 24, 36. And there's more, guys, we can continue. But the multiples of 18 are 18, 36, and you could continue forever. If you look at the multiples of 12, you actually see that the first lowest common multiple that emerges or that we see or find first, lowest, okay, look at 12, look at 18, nothing is common there. Look at 12, look at 36, nothing is common there. Look at 24, look at 18, there's nothing common there. But look, the first number common for both 12 and 18 is the number 36. So we say that the lowest common multiple is 36. Why? This is a multiple, obviously, of both of the numbers. It is common for both 12 and 18, and it happens to be the lowest number which is common between 12 and 18. So this was a method that was used in primary. Get to grade 8, all of a sudden we say to you guys, well, to find the lowest common multiple, we could apply a method of basically finding the prime numbers. Okay, the prime numbers. Guys, what is a prime number? A prime number is a number that has two factors. A prime number is a number that has two factors. Usually those factors are one and itself. Now, maybe someone is like, what is even a factor? You are speaking a language that I don't understand. A factor is a number that goes or fits into another number and leaves no remainder. Okay, so for instance, let me just give you an example. If you have, or you look at the number 18, the number 18 has a factor of 1. In other words, 1 is a number that goes into 18 and it leaves no remainder. In actual fact, 1 goes into 18 times. There are other numbers that go into 18. 2 is a number that goes into 18. It goes into 18 9 times. So that means that 9 is also a factor. 18 is also a factor of 18. 3 goes into 18. How many times? 6 times. So all of these are what we call factors. Factors are numbers that fit into another number or go into another number without necessarily leaving a remainder. No remainder. It fits in perfectly into another number. 1 fits into 18 times, 2 fits into 18 9 times, 3 fits into 18 6 times. Therefore, all of these are factors. But from those factors, there are those numbers that we refer to as prime. Prime what? Prime factors. Why do we call them prime factors? Because these factors are actually prime numbers. What is a prime number? A prime number is a number that has two factors, 1 and itself. Okay, so 2 and 3, if you want to find the factors of 2 and 3, it's 1 and 2. What is the factors of 3? 1 and 3. So that's why we say 2 and 3 are prime numbers. Okay, so I hope now we have a clarity. What is a prime number? It's a number that has two factors, 1 and itself. What is a factor? A factor is a number that fits into another number, or it divides into another number exactly without leaving a remainder. Okay, so that is just clarification for you when it comes to that. So here we can use what we call the ladder method. We simply identify the very, very smallest prime numbers that go into 12. Now think about it. What is the smallest prime number that goes into 12? Apply some thought. Smallest prime number that goes into 12. Tell me now. The smallest prime number that goes into 12. Trey Hack, 1 is not a prime number. Okay, so let's carefully just clarify something. The number 1 is not a prime number. Okay, because 1 does not have two factors. 1 has only one factor, and it's just itself. 2 is the smallest prime number that goes into 12. Question is, how many times does 2 go into 12? How many times does 2 fit into 12? Trey Hack. Well, if you disagree, then I guess it's okay. You can disagree. But I want you to then go and investigate it for yourself. Okay? Yeah, just go and investigate it for yourself. Even if you are saying in further maths and so forth, 1 is not a prime number. We don't regard 1 as a prime number. Okay, but anyways, I'm not here for that, to engage in serious combat and argument about that. It's worth going and looking at. 2 goes into 12 how many times? You guys have answered correctly. 2 goes into 12 6 times. I then think again, what is the smallest prime number that goes into 6? Because I want to write that down here. The smallest prime number that goes into 6, indeed, it is what? 2. 2 goes into 6 how many times? That is the question. 2 goes into 6 how many times? Thank you, Ndlovukazi and Tikherba. 3 times. The smallest prime number that goes into 3. Okay, very good. 3 is the smallest prime number that goes into 3. How many times does it go into 3? Once. And we stop right there, because as we acknowledge, or as we said earlier, we're not going to write 1 here, because here we are listing prime numbers, and by that the smallest prime number. Then what emerges on the right is basically how many times does that prime number go into the other. Okay, now we can say 12 is equal to 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 gives us indeed 12. So then we can say 12 is equal to, how many 2's do we have? There's 2 2's, so it's 2 squared. We express 2 times 2 in exponential form. We express 2 times 2 as a exponent. Then we multiply that by 3. We are done. This is what we call writing 12 as a product. Product means multiply of prime factors. We've just written 12 as a product of prime factors using the ladder method. Let's go do that now with 18. We ask the same question. What is the smallest prime number that goes into 18? Smallest prime number that goes into 18. Tikherba, Roblox. Yes, very good. 2 goes into 18. How many times? How many times? Tikherba, thank you so much. 9 times. Smallest prime number that goes into 9. Ati Kherba is like living it up. Ndlovukazi, yes. Roblox, very good. Monica Gegana, very good. Smallest prime number that goes into 9 is 3. How many times does 3 go into 9? We count 3, 6, 9. How many times does 3 go into 9? I'm sure you can see, guys. Or you can say 9 divided by 3. 3 goes into 9 how many times? 3 times. So we have 3. Smallest prime number that goes into 3. 3. How many times does it go into 3? Obviously, once. We get to 1, we stop right there. Then now we can write 18 is equal to 2. We have 1, 2, 3, 3 times 3. And we can check that 3 times 3 is actually 9, and 9 times 2 is 18. So if we write this now as a product of prime factors in exponential form, it means 18 is equal to 2 times 3 squared. Our objective is to find the LCM. So step 1, letter method. Step 2, write the numbers as product of prime factors. Step 3, we now are going to identify a common base with your highest exponent. All right. And even for the bases that are not common, let's say a base is not common, we are still going to identify it and make sure we select that unique base that has a highest exponent. And we are going to write those as a product of each other so that we can have the LCM. So if we look at 12 and we look at 18, 2 squared and 2 are common. But we are going to select that base 2 that has the highest exponent. But even if 2 wasn't common, if 2 was unique and it has the highest exponent, we would include it here as part of the product, which leads us to getting the LCM. So the base with the highest exponent for 2 squared and 2 is going to be, we select 2 squared. We are done with base 2. We move on to the next unique base, and that is base 3. It just so happens that base 3 is common, so we choose the base with the highest exponent. So that means we multiply 3 squared. So the product of the bases with the highest exponent, the product of the bases with the highest exponent gives me my LCM. What is 2 squared, guys? It is 4. What is 3 squared? It is 9. What is 4 times 9? It is 36. So my LCM, when I use the ladder method, gives me an LCM of 36. Not yes. So if you remember, I initially told you that as per your primary education in primary school, you guys may have just for getting the LCM between two numbers, you wrote the multiples out of the respective numbers and then you identified the lowest common multiple. And that was basically how you did it. In grade 8, all of a sudden, because we are laying the foundation for other important concepts that are going to unravel in grade 9, 10, 11, and 12. We teach you how to find the LCM using the ladder method, which simply starts out by identifying prime numbers that are divisible to the initial number, and we identify the product of those prime numbers, and then we express those in exponential form, and from there we identify the base with the highest exponent. Initially the common base with the highest exponent, but any other unique base is also multiplied, considered into the product of what then gives us the LCM. Let's come here. They want us to find the LCM of 3 and 12. LCM of what? 3 and 12. So, of course, multiples of 3, 3, 6, 9, 12. Multiples of 12, 12. LCM, 12. Straightforward, to the point, we can get the LCM of 3 and 12 doing that. If we do the ladder method approach, step number 1, 3 and 12. We find the prime number that goes into 3. What is the prime number that goes into 3? Identify that for us very quickly. Prime number that goes into 3 so that we can simultaneously go ahead and find the prime numbers that go into 12 and then get the product of prime numbers and then be able to write down the LCM. So this prime number, the smallest prime number that goes into 3. Do we know what the smallest prime number that goes into 3 is? Okay, hopefully we know it is 3. How many times does 3 go into 3? Once. So that means 3 is simply equal to 3. Smallest prime number that goes into 12. It is 2. How many times does 2 go into 12? 6 times. Smallest prime number that goes into 6 is 2. How many times does 2 go into 6? 3 times. Smallest prime number that goes into 3 is 3. How many times does it go into 3? Once. So the product of prime factors of 12 are 2 times 2 times 3, which means it's 2 squared times 3. So we can now then write 3 is equal to 3, whereas 12 is equal to 2 squared times 3. And remember, our LCM is simply this. We write down the product of bases with the highest exponent and we multiply them. If bases appear commonly, then we choose the common base with the highest exponent. So for instance, 2 squared, base 2 is unique to 12 alone. That means we are going to write 2 squared as the only standalone base that is unique with the highest exponent for base 2. Then we go to base 3. Base 3 is common, but the base with the highest exponent is simply 3. So then 2 squared times 3, that is 4 times 3, which gives us what, guys, for our LCM? It is 12. So that is the lowest common multiple between 3 and 12 using the ladder method. Okay, the common base, if the base is common with the highest exponent, we write that once. Then of course any other unique base, we regard that as a leftover. We take that base, as it is solitary, we include it because it is unique. It is the only one that is there with the highest exponent on its own. So we write it as a product to base 3, and then we get the final answer for the LCM. So LCM is attained in that way if we use the ladder method. Now let's turn our attention to something else. Not this time the LCM, but what we called the highest common factor. The highest common factor. The highest common factor. So how do we find the highest common factor when we are given numbers? Is it any, GRW, any? What's happening?
Why are you teaching us math?
Why am I teaching you maths?
What?
Why am I teaching you maths? Is that the question?
Yes.
Because I love maths, that's one. And then two, because I want to catch anyone that basically would want to be taught maths.
But this is grade 8. Some of us are not in grade 8.
Which is fine, because I guess grade 8s need it just as much as well. What grade are you in, Annie? Okay, Annie dropped off that call very quickly. I just wanted to ascertain what grade is Annie in. Yeah, guys, by the way, grade 8s and grade 9s are a neglected grade. Okay, and it's a common thing that grade 8s and 9s are neglected. You go to the school, to schools basically, you'll find that everybody is obsessed about grade 12 results. But where do grade 12 results get cooked? Where are grade 12 results cooked? If you have a solid foundation for your grade 8s with the maths, the likelihood is that the grade 10 and the 11 maths, when they choose the grade 10 maths, if the foundation is solid, then the likelihood is that they will be able to actually really maneuver well in the higher grades. Right, so that's the reason. I do understand that a lot of people that join my live lesson are pressed with their own demands as far as maybe the maths in their respective grades, especially the people that are in the grades that are higher. Grade 8s and 9s, when they come into the life, might not really care about what's happening because they are still full of a very playful mindset, which as I get and I understand. But if I can catch at least one grade 8 or 9 here and there, that is actually like, wanting to solidify their basics, I'm happy. Okay, so yeah. Do remember that there are times when I'm here and I'm doing work for grade 10. There are times when I'm actually on my other page, Maths is a Game, which has the white profile picture, and I'm doing grade 11 and grade 12 stuff. Like for instance, yesterday night I was doing grade 12 and grade 11 geometry for grade 11s and 12s. And yeah, it so happens that sometimes I'm doing grade 11 work, sometimes I'm doing grade 8 work, 9, 10, so it differs from time to time. Anyways, let's continue. Find the HCF of 12 and 30. So guys, now this time around, we're not finding the LCM, but the HCF. In earlier grades, when you found the HCF, you would actually write down, because remember, HCF means highest common factor. So HCF in earlier grades, you would write down the factors of 12. By factors of 12, we mean the numbers that go into 12 and leave no remainder. The first factor of 12 is 1. 1 goes into 12 times. After 1, you have the natural number 2. 2 does go into 12. How many times? 6 times. The next natural number 3 does go into 12. How many times? 4 times. Is there any other number that we may have missed that goes into 12? Are these all the factors of 12? So important for you to have all the factors of 12 listed. Are these all the factors of 12? Yes, they are. All of these are our factors of 12. Numbers that go into 12 without leaving a remainder. And I have captured all of them. Then we write down the factors of 30 as well. The first factor of 30, guys, is what? What is the first number that we know that goes into 30? 1. How many times does 1 go into 30? Goes into 30 times. Next number is 2. 2 goes into 30 how many times? 15 times. The next number is 3. 3 goes into 30 how many times? 10 times. Does 4 go into 30? No, guys. 4 is not a factor. If 4 goes into 30, it leaves a remainder, so 4 is not going to be accounted for. What about 5? Does 5 go into 30? Yes. 5 goes into 30. How many times does 5 go into 30? 6. The people that know their times table well, guys, will be able to have ease in getting these numbers. But of course, if you don't, you can always make sure that your calculator is close by and handy. Then the next number after 5 is 6. 6 is already there. I think we are done. These are all the factors of 30. Then what does the word highest common factor mean? It means from these factors, I'm going to go and identify the one that is common, meaning common means the same, but it has to be the highest number that is common. 1 and 1 are common, but that is not the highest number that is common. 2 and 2 are common, but that's the highest number that's common. 3 and 3 are common, but that's not the highest number that is common. 5 is not common. 4 is not common. 6 is common. Is 6 the highest number that is common between 12 and 30? Or is there another one? 12 and 10, 15, 30? There's no other. So the highest common factor between 12 and 30, we have to admit, is 6. This is how we navigated finding the highest common factor at primary level. We would write down the factors of each number. And the key thing here is to make sure that all the factors are represented. Remember, what did I say a factor is? A factor is a number that fits in to another number and leaves no room. Fits in and leaves no room. It's like a hand and a glove. Hopefully the hand fits in perfectly into the glove, does not leave a remainder. So we could say that the hand is the factor of a glove. It's like a foot and a sock. Hopefully the foot fits into the sock and leaves no room. So likewise, we are saying these numbers are all factors of 30 because they fit into 30. They don't leave any room, or we say they don't leave any remainder. When we have all of the factors represented, then it becomes easy to identify the highest common one of those factors. So there, in this case, it is beautifully the number 6. And really, we cannot argue that fact. It is just as nice and straightforward as you see it. You come to grade 8, all of a sudden, the learners get taught how to find the highest common factor using Mr. Ladder method. So let's investigate how that is done. So once again, we have the famous ladder, one with 30, the other one with 12. Okay, then what do we want to find? Remember, what do we write here? The smallest prime number that goes into the number and each successive number that we find on the right side. So remember, prime numbers, we said a prime number is a number that has only 2 factors, 1 and itself. And I think if we do to adjust to write down the prime numbers that are between 1 and 10, these are the prime numbers 2, 3, 5, 7. So at least we have a basic basis to work on. Of course, we should know all the prime numbers between 1 and 100, so that by so knowing those prime numbers, we can utilize them whenever the occasion requires. Okay. So what is the smallest prime number that goes into 12? Let's see, guys. Let's be active now. In the comment section, help me out. The smallest prime number that goes into 12. Come on, my beautiful people. My beautiful grade 8s and 9 learners. I'm hoping parents are waking up their kids so that they can come and partake of this revision. This is term 1 revision. Why am I doing term 1 revision? Because I want when the grade 8s go back after Easter, when they go back to school, they should be ready to take down anything that comes their way in term 2. But the basics must be fine from term 1. So if they missed something, I'm here to close those gaps. 2 goes into 12 how many times? Guys, 6. I ask again, what is the smallest prime number that goes into 6? Give it to me. 1 prime Dex should be able to give me the prime number because his name is 1 prime Dex. Masambe no, siyokwenza imaths sipase no. 2 goes into 6 how many times? 2 goes into 6 how many times? I'm sorry guys, I'm a bit fluish. 2 goes into 6 3 times. Smallest prime number that goes into 3? Thank you, the boardist. No, thank you so much. 3 is the smallest number that goes into 3. How many times does 3 go into 3? Once. Thank you. Then it means 12. We are going to be able to write it's 2 times 2 times 3, which is 2 squared times 3. Let's go to 30. Smallest prime number that goes into 30? Smallest prime number that goes into 30. Luxem Zikwa Tsetse, Pretty Boy, Mama Princess, You Limakatso, Tsebo the Stylist, Terminator Tools, Eli Tseho Flake, Florama Florza, Kelly Emo, IA Nzungu. Smallest prime number, Bernard, thank you so much. Smallest prime number that goes into 30 is 2. How many times does 2 go into 30? Thank you, Nono. How many times does 2 go into 30, guys? 2 goes into 30. How many times? How many times? Thank you, Bernard. Thank you, Nono. 2 goes into 30. How many times? 15 times. Smallest prime number that goes into 15, guys. Smallest prime number that goes into 15. Very good. 3. How many times does 3 go into 15? How many times? Yes, thank you, Bernard. 3 goes into 55 times. How many times? What's the smallest prime number that goes into 5? Smallest prime number that goes into 5, guys. Smallest prime number that goes into 5. Very good, Bernard. 5 goes into 5. Very good. How many times? Yes, no. Masambe, no. FNIs, yes. Very good. So 30 then can be written as 2 times 3 times 5. So 12 is 2 squared times 3. 30 is 2 times 3 times 5. Okay. Step 1, letter method, prime numbers. Step 2, writing the numbers as products of prime factors. And obviously this is basically the place where I am going to select. What am I going to select for the highest common factor? Here I select the common base, guys, with the lowest exponent. The common base with the lowest exponent, guys, it has to be common. I choose and select only from the common bases. I do not select if something is not common for all the numbers. It has to be the base that is common for all the numbers. So for instance, 12 and 30 both have base 2, so that means base 2 is common. Selection here can be made. Base 3 is also common. Selection can be made. Base 5 is not common. Selection cannot be made. Cannot select here. What am I going to look for? The common base with the lowest exponents, and I'm going to multiply. So it's the product of the common base with the lowest exponent. So let's identify those. Between 2 squared and 2, who am I choosing? Who between 2 and 2 squared has the lowest exponent? Who has the lowest exponent, guys? Is it 2 squared or is it 2? Remember, the exponent for 2 here is 1. You don't see that exponent 1, but it is there. So who has the lowest exponent? He has the lowest exponent. So I'm going to say 2 times. Then 3 and 3 are common. They both have the exponent 1. So I just choose a single 1 base that will represent for base 3. What is 2 times 3? It is 6. So here lies the highest common factor. I chose the, basically it is, highest common factor is the product of the common base with the lowest exponent. It has to be chosen from the common base. Okay, let's just say in this moment we were asked to find the LCM. Okay, we would do the same process, ladder method, product of prime factors. And when we are here, what are we interested? We are interested in the product of the common bases for 1, right? That has the highest exponent. But also we are interested in the unique bases. Right? So the product of all of that will basically lead us to the LCM. So what would we do if we're choosing the LCM? Base 2 we would choose from, definitely, but then we would choose 2 to the power what? We would choose 2 to the power 2. Then we would multiply that 2 to the power 2. We'd look at 3, we choose what? 3. Then from 5, could we choose? Yes, because leftovers or unique bases are also included in the LCM. So we choose bases with the highest exponent, okay, for anything and everything that is common. But then if there's anything unique, all right, and it's a separate, different base, we also select that into there, and the product of all of that gives us the LCM. So that's 4 times 3 times 5, 12 times 5, which we know 12 times 5 is 60. So the LCM of 12 and 30 is 60, whereas the highest common factor is 6. So distinguish and differentiate, guys, when I'm asking you to find the LCM as opposed to finding the HCF. HCF will always be the common base with the lowest exponent. The product of that is what gives me the HCF from my product of prime factors. The LCM, on the other hand, is the common base with the highest exponent, but also I consider any unique base that has a highest exponent if it is on its own, or if in those bases you can select the one with the highest exponent, you also include it as part of your LCM. The product of all of that gives you the LCM. Okay, now we're moving nicely. 48 and 76, what do they want? The HCF of 48 and 76. So let's do this exercise again using the ladder method. We have 48 here, we have 76 there, and what we want to do is identify first the prime numbers, the smallest prime numbers that go into 48. Guys, don't be scared there to support the live creator. Okay, I know I have quite lofty goals in my gift gallery, but if you are unable to support that, please, anything is welcome. Roses are sweet, populars are great, you awesomes are amazing, you know, heart me's are great, and so forth and so forth. So what do we do here? We identify the smallest prime number that goes into 48. We want the smallest prime number. We choose, in actual fact, and identify your most smallest prime numbers that go into the numbers that we see on the right side. And as we identify the first, it then leads us to another number, and we identify the prime number that goes into that subsequent number that we get until we get to 1, and we stop when there's a 1 on the right hand side of our letter. Okay. Prime numbers, guys, are numbers, as I said. Prime numbers are numbers that have only 2 factors. I said this earlier on. Prime number is a number that has 2 factors, 1 and itself. And then I said between 1 and 10, 2, 3, 5, 7 are prime numbers. Why do we say 2 is a prime number? Because if you think about the factors of 2, what are the numbers that go into 2? It's 1 and 2. What are the numbers that go into 3? It is 1 and 3. What are the numbers that go into 5? It is 1 and 5. What are the numbers that go into 7? It is 1 and 7. That's why we say prime numbers are numbers that only have 2 factors. It's 1 and itself. 2, 1 and 2, it's 1 and itself. 3, 1 and 3, it's 1 and itself. 5, 1 and 5, it's 1 and itself. 7, the factors of 7, 1 and 7, it's 1 and itself. Okay, so please, guys, there shouldn't be any hassle identifying the smallest prime number. Okay, there are more numbers between 1 and 100, and it becomes your responsibility to actually print out that chart of prime numbers, stick it up on the wall where you can see it, it can be visible all the time, or ask your mom to laminate it for you and you can stick it up on the fridge so that every time you think of going to the fridge and getting your nice, you can have it there. You can save it as a screensaver on your phone, so every time you switch on your phone, it's there. You can know what the prime numbers are. Anyways, what's the smallest prime number that goes into 48? Does 2 go into 48 for instance? Because that's the smallest prime number that exists. Okay. 2 goes into 48. How many times? 24 times. You just say 48 divided by 2, that gives you 24. Okay. The next smallest prime number that goes into 24, it's also 2. How many times does 2 go into 24? What's 24 divided by 2? It's 12. What's the smallest prime number that goes into 12? It's 2. How many times does it go into 12? 6 times. Smallest prime number that goes into 6, it's 2. How many times does 2 go into 6? 3 times. Smallest prime number that goes into 3? 3. How many times does it go into 3? Once. Done. Here are the numbers that when you multiply together will give you 48. These are prime numbers. So we take 48 is equal to 2 times 2 times 2. How many 2's do you have? 1, 2, 3, 4. So that's 2. How many 2's? 4 of them times 3. That is the product of prime numbers of 48. It's 2 to the power 4 times 3. Let's go to 76 and identify the prime numbers of 76. that go into 76. The smallest prime number that goes into 76. Smallest prime number that goes into 76. What is the smallest prime number that goes into 76? It's 2. How many times does 2 go into 76? So you take your calculator if you don't know what 76 divided by 2. Okay. These are like the important things that you need to make sure that you know. 38, not 32, 38. Okay, 2 goes. Kutumela, thank you so much for saying that I don't know maths, because I actually honestly believe the same thing. I don't know maths. I really don't. I'm trying to understand it and perceive it better. So hopefully one day, I will be able to know it better than I know it now. I don't know if I'll ever be able to know it actually, but I'm just hoping that every day I can know it better than I knew it previously. Okay, so shoot a man for trying, for crying out loud. Sure. Jeez, guys. Okay, thank you, Nono. My bet, I use my head. Okay, no problem. Okay, let's get that head to become a little bit more refined so that it can give you the right answers. No problem. I also used my head. I didn't use a calculator. Smallest prime number that goes into 38. That's also going to be 2. How many times does 2 go into 38? 19. Okay. What is the smallest prime number that goes into 19? Now from 1 to 10, there's no prime number that goes into 19. Then from 10 to 20, the only prime number that goes into 19 is the prime number 19. And how many times does 19 go into 19? Once. You see? So 76 is going to be equal to 2 times 2 times 19, and that is actually 2 squared times 19. So let's come down now and compare. 48 is 2 to the power 4 times 3. 76 is 2 to the power 2 times 19. So that means then for our HCF, for the what? Our HCF, base 2, common base with the lowest exponent. Remember, for the HCF, we have a obsession that we have to identify. The base that we identify has to be the common one. It can't be anything else. So I'm going to see, can this be my place of selection? Yes, because base 2 is common. Can 3 be my place of selection? No. Can 19 be my place of selection? No. Why? Because 19 and 3 are not common. They are unique. And for my HCF, I don't ever choose from something that is not common. It has to be common, right? So the base with the lowest exponent is 2 squared, right? And then what is 2 squared, guys? It is 4. So our highest common factor is 4 because we choose the common base with the lowest exponent. Okay. What if we had been asked to find the LCM? We'd still come here, right? And remember, for the LCM, it's the product of those bases with the highest exponent. But then we choose also from the unique ones. Okay. So for our LCM, leftovers are also included. So 2 to the power 4 and 2 to the power 2, we choose the common base with the highest exponent. That's fine. 3 is unique. There's no one like it, so we include it. 19 is unique, So we also include it in our product because 3 stands as the only base with the highest exponent. 19 stands as the only base with the highest exponent. Hence, I am saying L for LCM, I usually say we also check for common bases from the leftovers. And we identify the base with the highest exponent. 3 is the only one, and 3 becomes the base with the highest exponent for just 3 on its own. 19 is the only one, it's the only leftover, so it becomes the only base with the highest exponent, even though it's not common. So then you take all of this, 16 times 3 times 19, then you will get the value of your LCM. What is the value of our LCM, guys? Let's see if someone can actually find out for us what 16 times 3 times 19 is. What do you get? It's like 48 times 19. What is 48? Because 16 times 3 is 48. And 48 times 19, what's 48 times 19? Well, you look at that. Figure Sandakhatebe 912. Effie nice, thank you. 912. Thank you. So that is my LCM. Okay. All right. Let's move right along. Please, guys, send me your hot meal. Daily hot meal is really nice. It's really nice when I get those daily hot meals. Currently, we have 5, and therefore, like, the level of popularity of this live they definitely takes a dive. And also, if we can't, can you just double tap on the screen so that we can like the live, so that more people can hopefully get exposed to what we are doing here. It's always nice. Please share out the live with your friends, especially your friends in grade 8 and 9 that may possibly gain something from being here. Okay, let's answer that in the next few questions. We've been able to answer highest common factor and lowest common multiple questions using the ladder method. Previously, we were dealing with the addition and subtraction of integer values and the natural numbers, whole numbers using BODMAS, multiplication and division. We had initially looked at the property of numbers and how to apply those properties, commutative property, associative property, distributive property, and so forth. Now we are moving very swiftly to the next thing. The natural number 48 is given. Write down the factors of 48. Let me allow you guys to write down those factors in the comment section. Remember, when they say write down the factors of 48, all of them need to be there. So let me give you guys a chance. What are the factors? It says here, write down the factors of 48 for 2 marks. Remember, if you don't write down all of the factors, you miss one number, then you lose marks. All right, you may end up not getting even a mark, getting 0, because it's either you write down the factors, all of them correctly, or you don't write them all correctly. If they say write down the factors of 48, all of them must be there for you to get 4 marks. Getting half marks or not getting all the marks is just a no. It's a no. So what are the factors of 48, guys? Comment section. For 2 marks, write down the factors of 48. 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 The numbers that fit into 48 without leaving a remainder. Nice has just written down his response or her response. And for that, I'm going to follow you back. For just your response, I'm going to follow you back. For just that response, I'm going to follow you back. Okay, are those all the factors from Nice? It seems like I would say those are all the factors represented. Okay, it's a pity I was trying to pin your comment, but it seems like my device is not allowing me to. Okay, so let's just check these factors. Effie Nice first wrote down 1. I like writing down the factors and writing them down as twins. For instance, I ask myself, if I say 1 is a factor, then I ask myself, how many times does 1 go into 48? That way, I can get the accompanying factor of 48. 1 goes into 48 how many times? Or what is 48 divided by 1? And you could simply use your calculator for that, okay? 1 goes into 48 times. That way, I know the first factor and the last one. These are twin factors. Then you ask yourself, the next natural number after 1 is 2. So you see, that's where R falls short, because R wrote down 1, but R forgot to write down 2, because R did not take the step-by-step approach. So the next number after 1 is 2. Does 2 go into 48? Yes. Yes. Does 2 go into 48? Yes. Oh, he left out 16. That's true. No. Wow. No. Okay, I think for that, no. I want to follow you back. No. Just no. Yo. I don't mess with no. Okay, no. Let me just see your account and you follow you back. There we go. Okay, no, 100%. So 2, does 2 go into 48? Yes. How many times? 24 times. Next number, 3. Does 3 go into 48? Yes. How many times? 16 times. That's what I'm saying, guys. You need to do these in pairs. Does 1 go into 48? Yes. How many times? You take your calculator, say 48 divided by 1, you get 48. Does 2 go into 48? You can check with your calculator. 48 divided by 2. If you get a natural number, it means 2 does go into 48. What's 48 divided by 2? You get 24. You write down 24. Does 3 go into 48? You say 48 divided by 3. You get what? 16. So it means 3 goes into 48 16 times. You write down 16. Does 4 go into 48? Yes. You say 48 divided by 4. You get what? 12. You write down 12. Does 5 go? No. Does 6 go? Yes. 6 goes into 8 how many times? Into 48 how many times? 8 times. Does 7 go? No. Does 8 go? Yes. We have 8 already recorded, so that means that's where we stop. These, I know for a fact, I've recorded all the factors. So please, guys, when you are asked to write down the factors of a number, please do it in pairs. Why am I saying do it in pairs? In that way, it will ensure that you don't miss a number. Right? Imagine I say I'm going to take the members of your family to your best holiday destination, and you guys are going to fly first class and so forth. What happens if I so happen to forget you as a member of the family and I don't take you along, but it's your desired holiday destination? You would feel bad. You would feel like a bag of sand. Okay, so that's like forgetting a factor when you are asked to find the factors. No identified that you guys forgot 16, right? And that basically will lead to you losing and not getting all the marks. So please, guys, let's make sure when we write down these factors, we're writing them down 100% correct. Okay? I beg. Would you not get your full 2 marks here? Oh, definitely. You'd get your full 2 marks. Right? And for everything else above, you would get your marks. 2 marks in the bag. Let's turn over the page. Now they are saying, write down the prime factors of 48. Okay. This question is easy to answer, knowing that I've answered first how to find the factors of 48. Remember, they are saying write down the prime factors. All they are simply saying to me is come here where you wrote down all the factors and identify the numbers that are prime. So is 1 a prime number? No. Is 2 a prime number? We are going to take 2. Is 3 a prime number? We are going to take 3. Is 4 a prime number? No. Is 6 a prime number? No. Is 8 a prime number? No. Is 12 a prime number? No. Is 16 a prime number? No. Is 24 a prime number? No. Is 48 a prime number? No. By the way, the interesting question for you guys, if 2 and 3 are prime numbers, what is 4 and 6 referred to? 4, 6, 8, 12, 16, 24, and 48. What type of numbers? If they are not prime numbers, what do we call 4, 6, 8, 12, 16, 24, and 48? What is the opposite of a prime number? The opposite of a prime number, we referred to those family of numbers as what kind of numbers? Why didn't I identify 4, 6, 8, 12, 16, 24, and 48 as a prime number, but 2 and 3 were identified? What do we call this family of numbers? 4, 6, 8, 12, 16, 24, and 48. Okay. I want to tell you now, we call them composite numbers. We call them composite numbers. What are composite numbers? These are numbers that have more than 2 factors. Okay. What do we call them? Composite numbers. So 4, 6, 8, 12, 16, 24, and 48 is what we call a composite number, because these are numbers that have more than 2 factors. Okay, more than 2 factors. So understand that, guys, and understand it well. Otherwise 2 and 3 are basically prime numbers, and so because they are prime numbers, we say these are the only prime factors that we have of the number 48. So when I come and answer this question, write down the prime factors of 48. Here they are. The prime factors of 48 is equal to 2 and 3. There they are. These are the prime factors of 48. So I'm going to get my 2 marks happily, because the question here says write down the prime factors of 48. I go to the factors of 48 which I wrote down. I identify the 2 numbers that are actually prime numbers. Those are the prime factors. Okay. All the other numbers, if the question had said write down the composite factors, this question could have said write down the composite factors. Let me just do that now. Write down, let's add a question. Write down the composite factors of 48. Had that question been asked to write down the composite factors of 48, then I would have gone back to these numbers and I would have written down 4, 6, 8, 12, 16, 24, and 48. 4, 6, 8, 12, 16, 24, and 48. The number 1 is not going to be included there because 1 does not have more than 2 factors. Okay, guys, 1 is neither a prime number and it's neither a composite number. Okay, but 4, 6, 8, 12, 16, 24, 48. 4, 6, 8, 12. Let's write these down. Composite factors. 4, 6, 8, 4, 6, 8, 12, 16, 24, 48. These would be what we call our composite factors of 48. And if there was a mark allocation, that mark allocation I would get straightforward. Okay, and without making any fun, we'll get those marks. Okay, I hope that makes sense, and it makes sense very well. Okay, let's move on. Write 21 as the product of two prime numbers. Write 21 as the product of two prime numbers. Okay, write 21 as a product of two prime numbers. So I'm sure you guys know how to do that. Smallest prime number that goes into 3 is, into 21 is 3. It goes into 21 how many times? 7 times. Smallest prime number that goes into 7 is 7. And it goes into 7 once. So the product, writing 21 as the product of two prime numbers, 21 is equal to, first prime number is 3, and then the second prime number is 7. 21 as the product of two prime numbers is 3 times 7. That is what 21 is, as a product of two prime numbers. Okay. Yeah. Nowadays, when you have a Casio calculator, it's easy to just say 21 is equal to, you press your calculator, say 21 is, you press 21 equal, you press shift, and then from that shift you go and actually select that button that has a yellow fact, and what you will get is, you will get exactly your product of prime factors for that specific number. Okay, without necessarily having to use the calculator. So without necessarily having to use the ladder method. Okay. Let's go on. Write 18 as the sum of two prime numbers. Write what? 18 as the what? The sum of what? Two what? Prime numbers. Write 18 as the sum of two prime numbers. Now we know that 1 is not a prime number. We know that for a fact. Okay. Fake maths. Okay, no problem. Always me. Yeah, I think it's always you. I think, I see now this name of yours. Always me. So when you say fake maths, then you know whatever you are saying is always you. So it must mean that the fake maths is with you. What a name. So we write 18 as the sum of two prime numbers. Okay. Coming from 18, all right. Think about it. Okay, it's a matter of trial and error. 17 is a prime number. If we add 1, we get 18. The only problem is that 1 is not a prime number, so we can't qualify that. If we come down to 16, 16 with 2 gives us 18, but 16 is not a prime number. We go down, 15 plus 3, that gives us 18, but unfortunately 3 is a prime number, 15 is not. Go down to 14, 14 plus 4, these are both not prime numbers. We go down further, 13 plus 5. Oh, what do you see here? The number 13 is a prime number. The number 5 is a prime number. What's 13 plus 5? It's 18. So all I did here was just descend from 18, consider 17, and obviously the number that would give me 18. 17 plus 1. Okay, this was definitely not. This is a prime number, but 1 is not. 16 is not a prime number, that is. 15 is not a prime number, that is. 14 is not a prime number, and 4 is not a prime number. But 13 and 5, guys, 13 is a prime number, and 15 is as well. From 17, 16, 15, 14, 13, as I descended, I increased in my natural numbers. 13 plus 5. So the sum of two prime numbers is actually 15 plus 13. So here we just needed to think a little bit outside the box. Okay, and this is something we need to cultivate as learners. Being able, sorry, not 15 plus 13, 15 plus 3. We need to be able to cultivate the art of thinking outside the box. Okay, so 15 plus 3. Writing 18 as the sum of two prime numbers means 15 plus 3. Okay, that's what it means. All right. Can we continue? I think we can. We can continue, né? Write each of the following numbers as the product of its prime factors. So who helps you out very nicely with that? It's Mr. Ladder. No, please repeat the last problem. The question said write 18 as the sum of two prime numbers. What does the word sum means? It means the addition of what? Of two prime numbers. So it must be two prime numbers that we are adding. Write 18 as the sum of two prime numbers. Yes, this is for grade 8 and 9. Okay, but these are basics for the grades that are above as well. The funny thing is, grade 12s and 11s forget simple basic concepts as this, and then they struggle to answer questions in their specific topics that they are doing in grade 11 and 12 and 10. So I always say that doing these is basics for later grades, and you grade 12 learner and 11 learner and 10 learner won't lose anything by actually subscribing to what's happening here. Write 18 as the sum of two prime numbers. 18 must be written as the sum, the addition of two prime numbers. So what I did is I looked at what forms 18. Okay, so you could say like 1 plus what gives you 18? It's 1 plus 17. These two numbers, are they both prime? 1 is not, 17 is. So I go to the next number, 2. 2 plus what gives me 18? It's 16. Okay, 2 plus what is 18? It's 16. 2 plus 16, are these prime numbers? 2 is, 16 is not. So I'm doing trial and error here. Next number, 3. 3 plus what gives me 18? It's 15. 3 plus 15, is 15 a prime number? No. Is 3 a prime number? No. Man, I wrote the wrong thing here. Sorry, man. 15 and 3 are not prime numbers. 15 is not a prime number. 3 is a prime number. The next one, 14 plus 4. Is 14 a prime number? No. 4? No. 13 plus 5. Okay, I'm just increasing in my natural numbers and then getting the next number. 5 plus what gives me 18? It's 13. So 5 plus 13, is 13 a prime number? Yes. Is 5 a prime number? Yes. So 18, guys, written as a sum of prime numbers is 13 plus 5. Sorry guys, I made a mistake earlier on. I wrote this pair instead of writing the pair that I had selected. Is 13 a prime number? Yes. Is 5 a prime number? Yes. So 13 plus 5 is 18. That is a sum of two prime numbers. Yeah, thank you for actually saying I must go back to that, because I actually did not see that I had made an error there. Okay, write each of the following numbers as the product of its prime factors. So let's think of prime numbers that go into 148 so that we can be able to then formulate the product of prime factors. So what is the smallest prime number that goes into 148? Okay, we are thinking in that line. Smallest prime number that goes into 148. We think of those numbers. Smallest prime number that goes into 148, it is 2. How many times does 2 go into 148? It goes into 148 74 times. Smallest prime number that goes into 74 is 2. How many times does 2 go into 74? It goes into 74 37 times. Smallest prime number that goes into 37, it is 37 because 37 is a prime number. How many times does 37 go into 37? Once. You can then grab your calculator just to confirm. You say 148 is equal to shift, then you press fact. 148, you type in 148, you press equal, you press shift in your Casio calculator, and then you press fact. You will get the product of prime factors. That 148 is equal to 2 times 2 times 37, which is actually 2 squared times 37. That's 148 as a product of prime factors. Straightforward. Straightforward. Letter, answer. Letter, answer. 148 as a product of prime factors is 2 times 2 times 37, which is 2 squared times 37. So figure us under Khatebe. Hopefully you're following with us there. No. Hope you are okay there. We get the flow of how we go about answering questions related to finding the product of prime factors in grade 8 and 9. We just use the letter method, and then we can confirm our answer even with this guy. 148 is equal to shift fact. You can just get to see that, oh, indeed it is 2 squared times 37. That is basically the product of prime numbers. Okay. Moving right along, we are asked to do the same thing, find the product of prime factors for 360. So we laderize, we 365, we ask what is the smallest prime number that goes into 360. Again, smallest prime number that goes into 360, it is beautiful number 2. How many times does it go into 360? 2 goes into 360 how many times? 180. Smallest prime number that goes into 180, 2. How many times does 2 go into 180? 90. Smallest prime number that goes into 90, 2. How many times? 45. I'm sorry for the sounds that my beautiful stomach is making. Hunger is upon me. That's why you guys should send me gifts if you can, with the roses and with the ice creams and with the You Awesomes and with the Populars. And, okay. Smallest prime number that goes into 45 is 3. How many times does it go into 45? 15 times. Smallest prime number that goes into 15, it's 3. How many times does it go into 3? 5 times. Smallest prime number that goes into 5 is 5. How many times does 5 go into 5? Once. We stop right there. So 360 is equal to 2 times 2 times 2. How many 2s? 1, 2, 3. How many 3s? 1, 2. How many 5s? 1, 5. How many 2s? 3 2s. 3 2s. How many 3s? 2 3s. How many 5s? 1 5. So 360 is equal to Shazam. Shazam! 1 mark here, 2 mark there, 3 marks, beautiful marks there. Maybe the 2 marks will be devoted to the letter because the letter took quite a bit to actually get to the answer. So yeah, this is how we write a number as a product. Product means multiplication of prime factors. Prime factors, these are bases that are prime numbers, and these are all prime numbers. So that's why we say we're writing a number as a product of its prime factors. Okay. Simplify the following without using a calculator. Step by step, no calculator. Okay, we are back here again. Step by step without using a calculator. Square root of 16 inside another square root. So our focus will be from within, then we go without. So the square root of 16 gives you 4. The square root of the 16 inside is 4, right? Which means that square root is removed, we get 4 inside the square root. Then the square root, this one is still there, so the square root of 4 gives you 2. How many marks? 2 marks. And obviously when they say simplify the following without using a calculator, it means every step needs to be shown. 1, 2. See? If you simply went and typed this into a calculator and wrote the answer, you would not get the 2 marks because you didn't show the initial step that led to the final step. Okay, so please guys, take things one step at a time. I'm saying there are 2 square roots, but when you are going to focus on the square root within, and then you go out. You see, this is like an inside out job. When you want to change in life, your thought life first needs to change. You can't just change by your actions. Your thought life, how you think, needs to first change. And what you think needs to be influenced by something that you receive as knowledge and information coming in. So it's important to then feed your mind and your heart with positive, concrete, good knowledge. And then as you begin to shape and reshape the way you think, then the change will happen from the inside out. So that's what happened here. Apply the square root of 16 inside, you get 4. So this square root disappears once you apply the square root of 16 to 16. Once you apply the square root to 16, you get 4. Then there's this square root which remains. So that square root that remains, you apply it now as your final step. Square root of 4 is 2. So that's basically how we do it step by step. Let's look at the next one. Square root of 4 plus square root of 9. Square root of 4 is 2. Square root of 9 is 3. 2 plus 3 is 5. I think we guys get the point there. And 1 mark, 2 mark. Applying the square root to each number and then getting your final answer. Okay. Nelo, what's up? What's down?
Hello.
Nelo.
Hey.
Did Nello request on purpose or did you request by mistake? Yeah. Okay. See, look at this one. The square root of 3 squared plus 4 squared. Can we split the square root? We can't. Why? Because there's a plus sign in between the two numbers. The only way we could split the square root is if there was a multiply and a divide between 3 squared and 4 squared. But since there's a plus, we can't split. Okay? We can't split the square root. So here we focus on what's inside. What's 3 squared? It's 9. What's 4 squared? It's 16. That's step number 1. Can we split the square root still? No, because there's a plus sign in between. 9 plus 16, guys, is 25. We can't split the square root if there's a plus and a minus sign in between. Be very careful, guys. We cannot split the square root if there's a plus and a minus sign. So we add 9 plus 16, we get 25. What is the square root of 25? It is 5. People make the misconception of applying the square root to 9 and 16 individually, and then they think that that's the answer. No, you can't do that. When there's a plus and a minus sign in between, we don't split the square root. So we add the numbers 9 plus 16, we get 25, the square root of 25. Now we can apply the square root to 25 as a single number. We get the answer of 5. It's as simple as that. Okay. So let's be careful there. Okay, take note, guys. Take note of these things. I'm emphasizing things here that you guys tend to take for granted, and because you don't take those things seriously, you take them for granted. You continue to make silly mistakes and you continue to lose marks unnecessarily. Square root of 18 over 50. Okay, please note something here. 9 times 2, 25 times 2. What's 9 times 2? It's 18. What's 25 times 2? It's 50. So if I break up 9 times 2 and 25 times 2, this 2 and this 2, 2 divided by 2 is 1. That leaves me with 9 over 25 underneath the square root. Yeah. This is the same thing as saying, for instance, you could approach this question a bit differently, where you would look at inside the square root and you simplify 18 over 50. So what you say is, between 18 and 50, what is the highest common factor? Of course, the highest common factor between 18 and 50 is going to be your number 2. So you divide the numerator and the denominator by 2. That gives you 9 over 25 underneath the square root, which is basically the same place that I'm finding myself in, having used a different method. Here, 9 times 2, I split 18 to 9 times 2, and then 50 becomes 25 times 2. And the 2 divided by 2, basically you can cancel these 2, because you can cancel when there's a multiplication sign. Okay, you can't cancel when there's an addition, but you can cancel across a multiplication sign. So that and that cancels, you're left with 9 over 25 underneath the square root. Then there's the law that says you can split a root when you are dividing, or you can also split the root when you are multiplying. But you can't split the root if you are adding and subtracting. Guys, you can't do this. This is not allowed. Okay, this, guys, is wrong. these are correct. We can't split a root between addition and subtraction, but we can do so with division or multiplication between bases. You can split the root. So for instance, once we are here, 9 over 25, we can go ahead and say the square root of 9 over the square root of 25. You can split that, which will then give you an answer. The square root of 9 is 3, square root of 25 is 5. That is your final answer. Okay. Okay. Step by step, because what they want here is to see the steps. Okay, where is this coming from? It's coming from this idea. Or in reverse, if you have split roots for division, you can combine them again underneath one root. If you have split roots for multiplication, you can combine them again and multiply them under the same roof. Okay, let's continue. 11 1 over 9, the square root of 11 1 over 9. Now this square root here, we can first convert the mixed number to an improper fraction. How do we do that? We multiply 11 and 9 and then we add 1. What's 11 times 9? It's 99. What's 99 plus 1? 99 plus 1 is 100 over what? Over 9. Then we can write 100 over 9 underneath the same square root. Surely there would be a mark allocation there. What you see at the top, what you now see at the bottom is a single fraction. It's a rational in nature. Then, using what I've just learned about splitting the root, if a fraction is underneath one root, division is the relationship, I can split the root for division. So I'm going to say the square root of 100 over the square root of 9. Okay, you can split the fraction underneath the same root if the relationship is divide or multiply, but not when the relationship is addition and subtraction. So what is the square root of 100? It is 10. What is the square root of 9? It is 3. So the answer is 10 over 3. Okay, just like that, guys. Please, guys, you see, so those marks, got them because I'm showing step by step. Okay, took the mixed number, converted it into an improper fraction. My knowledge of fractions was needful here. And 100 over 9, 100 is a perfect square number, 9 is a perfect square number, and underneath the square root of a perfect square number at the top and at the bottom can easily be gotten. Square root of 100 is 10, square root of 9 is 3. So the answer is 10 over 3. Okay. Square root of 2304, and it's evident that because it's 3 marks, okay, So what I'm going to do is I'm actually going to apply the ladder method to simplify this, so as to make life easy. Okay, so let's check what are the product of prime factors. 2 goes into 2304 how many times? 1152 times, I believe. Okay, the next prime number that goes into 1152 is 2. How many times does it go into? 576. The next prime number that goes into 56, the smallest, is what? Is 2. How many times does it go into 2? Remember, guys, to find the next number, if you say 2, you can just take your calculator and say 2304 divided by 2, you get 1152. Then the smallest prime that goes into 1152, maybe you don't know how many times it goes in, so you say 1152 divided by 2, you get 576. Then you ask what's the smallest prime number to go into 576, it's 2. And you say 576 divided by 2, you will get 288. And you ask again, smallest prime number to go into 2 is 2. How many times does it go in? 2 goes into 288. How many times? 144. Smallest prime number goes into 144. Smallest prime number that goes into 144 is let's check if people know. Yes, it's 72. Smallest prime number that goes into 72 is 2. How many goes? 36. Smallest prime number that goes into 36 is 2. How many times? 18. Smallest prime that goes to 18 is 2. How many times? 9. Smallest prime that goes to 9 is 3. 3 goes to 9. How many times? 3. Smallest prime that goes into 3 is 3. How many times does it go? Once. How many 2's do you have? 1, 2, 3, 4, 5, 6, 7, 8. So you have 2304 is actually equal to 2 to the power 8. You have how many 8's? 2 of those 8's. And then how many 3's? You have 2 of those 3's. So what you can then do is that you can say the square root of 2304 is equal to the square root of 2 to the power 8 times 3 to the power 2. You split 2 to the power 8, you split 3 to the power 2. And then when you apply, guys, the root to the exponent 2 to the power 8, this is the same thing as 2 to the power 8 divided by 2 times, this is the same thing as 3 to the power 2 divided by 2. Because it is the square root, you divide each exponent by 2. Okay, if it was the cube root, meaning there would be a cube root there, you would divide each exponent by 3. If it was the fourth root, you would divide each exponent by 4. So there's this law that says the mth root of the a to the power n can be written as a to the power n over m. So you can remove the root and you can keep the exponent divided by the root. So that's where we get this. This is 2 to the power 4 times 3 to the power 1. This is 16 times 3, which is 48. So this is like step by step getting the answer to the square root of 2304 using the product of prime factors. Of course, if you do have your calculator, you could have said 2304 equal to shift effect, and then you could have gotten the 2 to the power 8 times 3 squared. You could have then put this underneath that square root, and then go ahead. You split, get 2 to the power 8 divided by 2 times 3 to the power 2 divided by 2, which is 2 to the power 4 times 3, which is 16 times 3, which is 48. So the square root of 2304 is actually equal to this 48. Okay, so remember guys, sorry, let me just remove the square root. You would have said 2304 is equal to shift fact to get these, and then you put it under the square root because this was initially written being under the square root, and then you simplify. Okay. Let's move. 2 root 3, the whole thing squared. What is the relationship of 2 and root 3? The 2 and the root 3 are multiplied together. What is the relationship of a times b to the power n? These are multiplied together. So what do? With multiplication, we can multiply the exponent. This is like saying 1 times n. This is like saying 1 times n. A to the power 1 times n times b to the power 1 times n. So 2 and root 3 are multiplied. So what do? We apply the 2 squared. We apply the root 3, the square. We can apply the square to the 2 and the root 3 separately. What is 2 squared? It's 4. What is the root 3 squared? A square and a square root remove, or they cancel each other. So we have 3. What's 4 times 3? It is 12. 1, 2, 3. You wonder why it's 3 marks. Okay. The relationship between 2 and the root 3 is one of multiplication. Like a times b is multiplied and there's an exponent on the outside. The law of exponent says the base a can be multiplied with the outside exponent, and base b can be multiplied with the outside exponent. So you distribute the n by multiplication to its current exponents. Okay, so that's why it's a to the power 1 times n times b to the power 1 times n. We do the same thing with square. Because 2 is multiplied to root 3, if the relationship is multiply, distribution by splitting can happen. If the relationship is divide, distribution with multiplication can happen. But if there was a plus and a minus, no, we can't. If there was a plus minus between 2 and root 3, we could not distribute the exponent to each base. So this is the same thing as this. I'm just gonna write a plus b, a over b to the power n. You can split the exponent and multiply it, a to the power n over b to the power n. That kind of like resonates with the splitting of the root. Here we are splitting the exponent. 2 if it's division, the relationship between bases. If it is multiplication, we are splitting the exponent by multiplication of that exponent with the exponent that is currently there on that particular base. So please guys, these are important rules in maths that if overlooked, they will take care of you and they will lead to your loss of marks. Then, like this law number 3, the minute we have plus and minus and there's an exponent on the outside, we cannot split the exponent. That's a no go zone. So you can split the exponent for division of bases, There you have it. Exponent is distributed to the numerator and the denominator. You can split the exponent by multiplication if the bases are multiplied, but you cannot do that with addition and subtraction. It's a no-go zone. So for instance, when you come to this problem, let me look at it again. This is 2 root 3. So in other words, this 2 is multiplied to root 3. They have a relationship of multiplication. You can split the exponent to 2 squared root 3 squared. You can split it, the exponent. You apply the exponent to 2, you get 4. You apply the exponent to the square root of 3, the square root and the square cancel each other, you are left with 3. Then it's 4 times 3, because brackets mean multiply. 4 times 3 is 12. Okay. Please, guys, as a matter of urgency, these rules and laws, take them seriously, because they are the ones that are the substance and the drive, of what we do. When you don't take these laws seriously, then it does have a way of just crippling in and affecting you when you answer your questions, because you carelessly answer questions but don't consider the rules that you're supposed to be applying as you are answering those questions. Guys, let's continue to double tap on the screen. Let's get the likes up there so that more people can come in and join. Share the live as well. We are here now. 4 minus 3 squared. Do you remember what we said here? Can we split the base and multiply the exponent to each base's exponent? Can we split it when there's a minus? This is 4 minus 3, the whole thing. Can we split this? Hopefully you know that we can't. But rather look at this. What's 4 minus 3? Boldness. 4 minus 3 is 1. 1 squared is equal to 1. Okay, so that's how we get that answer. Let's come here. 4 times 3, the whole thing squared. Can we split using exponents? Yes, because the relationship is one of multiplication. So you could say 4 squared times 3 squared, which is 16 times 9, which will give you the answer, which is 144. That's one way of doing this. Or you could say, what's 4 times 3? It's 12. What's 12 squared? It is 144. 2 ways of doing the same question. Right? And both ways are 100% correct. Okay. Yeah. Okay. Maybe, guys, we can hold it right there for today. Okay. Hold it right there for today. Check me live tomorrow morning again if you are in grade 8 and 9. And let's push the passion again tomorrow morning. Okay. Thank you so much for joining. I'm going to love and leave you now. Thank you for those that gifted. If you could, I really appreciate it. Thank you for those that were able to support the live goal, whether that be through double tapping, whether that be through sending whatever you can send when you can, and just being here as well, participating, sending your responses in the comment section. All of those things are really highly appreciated when people can do such things. And you guys have yourself a beautiful day further. I want to love and leave you. Take care and enjoy. And thank you for being here. It was great while it lasted, right? It was great while it lasted, right? Okay.